Simplifying radicals. So first of all, let's label the parts of what the radicals are. So this that you see right here, the number out front, that is our leading coefficient. Okay. Then what you may see on top, like a small little number, so I'm referring to this, the x, a small little number outside the root, that is called your index. That is telling you what kind of root you're taking. Now, if you look down to example 1, you can see that there's no number there, which means you're just taking a square root. Okay, so no root is just a square root. Okay, and then the number inside the radical for the y, that is called our radicand. Okay, so let's get into examples. Now, it is very, very beneficial for you to know what your perfect squares are. Okay, that will help you do this a lot faster, especially when you get down to example 2 and so on. So when I'm talking about perfect squares, I'll just do this at the top here. 1 squared is 1, so 1's a perfect square. 2 squared is 4, so we consider 4 perfect squared. 3 squared is going to be 9. 9 is a perfect squared. 4 squared is 16. 5 squared is 25. 6 squared is going to be 36. 7 squared, 49. 8 squared is 64. 9 squared is 81. And of course, 10 squared is 100. 11 squared gives you 121. 12 squared, 144. So what is super important for you to know is that 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, and 144. Those are considered to be perfect squared numbers. Okay, learn those if you don't already know, okay? And if you want, you can jot them down on your paper so that you always have them to look at. But if you know them by heart, it's just going to make your life a whole lot easier when you're doing this stuff. Okay, so for the first one, the square root of 16. Well, 16 is a perfect square. It's up in our list up at the top. So the square root of 16 is 4. Because when you're taking the square root, it's just asking what times itself is going to give you that number. When you have a variable, like on B, square root of x squared is just going to be x. Okay, that 2 is going to go away. We're going to get into variables a little bit deeper later. But for right now, if it's a square, if it's an x squared and you're taking the square root, it's just going to turn into x. All right, on C, we've got 2 parts. So square root of 25 is 5. Square root of y squared is y. All right, on D, cube roots. Now, it is also beneficial for you to know a few cubes. So I would at least know, for example, let's find some room here. So like 1 cubed is 1. 1's a perfect cube. 2 cubed. Now, this isn't 2 to the third power. This is 2 cubed, which means 2 times 2 times 2, which is 8. 3 cubed is 27. 4 cubed is 64. 5 cubed is 125. Now, I would recommend knowing 1 through 5 by heart, and then you can, use your calculator or whatever to figure out bigger ones. But if you know at least these, 1 through 5, that will really, really help you. Okay, so on D, our index, when I say index, I'm talking about this part right here. Our index is 3, so we're doing cube roots. So the cube root of 27 is 3, and then 3 to 3, that's just going to turn into an x. Okay, now we're going to get into simplifying. And I've got the steps over here to the side. So step 1, find a perfect square or cube that goes evenly into the radicand. Okay, so let's do that for A. So 50 itself is not a perfect square. But if we go and we look at our list up top, the perfect squared list, you want to find the biggest number that goes into 50 that I've got highlighted. So out of all those numbers that are highlighted, 25 goes into 50. So I'm going to rewrite it as 25 times 2, which is step 2. Step 2 is rewrite under the radical. I figured out 25 goes into 50. Well, 25 times what gives me 50? And that's 2. So I'm going to rewrite it just like that. For step 3, take the root of the perfect square or cube and move to the outside. So for example, and some people even like to split it up like this because it's less confusing to them. So you can go to that. So the square root of 25 turns into 5. Now, we can't take the square root. 2 is not a perfect square. We can't take the square root of it without turning it into a decimal. So you leave it just like that, and that will be your final answer. Okay, so we'll repeat the steps for B. Find the biggest number, looking at your list up top of those highlighted numbers, which one of those numbers is going to go into 24. And that is going to be 4. So we've got 4 times 6. Okay, if you want to rewrite it, it's 2 separate radicals. Square root of 4 is 2. And I always like to put that perfect square first instead of doing 6 times 4. I like to put the perfect square first, like the number that I had highlighted from a list. You can't take the square root of 6 without it becoming a decimal, so it stays as a radical. All right. And at any time, if you feel like you've got the hang of this, you can pause the video, try an example, and then play the video to see if you got it correct. That's what I would recommend doing, especially if you're this is one of your remote learning days and you're at home. So for 18, look at those highlighted numbers. What's the biggest number that's going to go into 18? And that's going to be a 9. Well, 9 times what gives me 18? 2. So square root of 9, square root of 2, square root of 9 is 3. I can't take the square root of 2 without being a decimal. So I leave it as a radical. All right, for D, what's the biggest highlighted number up there that will go into 20? And that's going to be 4. And what times 4 gives us 20? 5. Now, you may get to the point where you can like eliminate this step right here. So the square root of 4 turns into 2. 5 is going to stay in the radical. All right, for E, you've got square root of 12. The biggest number that goes into that is 4. 4 times 3. The square root of 4 turns into 2. 3 is not a perfect square, so it stays in the radical. All right, so for 54, 9 is the biggest number that goes into 54 times 6. And when square root of 9 is 3, 6 stays in the radical because it's not a perfect square. So the ones that are not perfect squares stay in the radical. So on these, we're not able to completely get rid of the radical. Okay, for G, we've got the square root of 30. So obviously it's got to be a number less than 30. But we've got 25, 16, 9, 4, and 1. We don't really count 1 because that's not going to help reduce it any. So 4, 9, 16, 25. None of those numbers go into 30. So this one can't be reduced. Okay, so for H, for 32, the biggest one of those highlighted numbers that's going to go into it is 16. 16 times 2. The square root of 16 is 4, and 2 stays under the radical. Okay, so for example I, you've got the square root of 28. 4 is the biggest number. 4 times 7. 4 is the biggest perfect square. Because remember, that's what you're looking for. You're always looking for the biggest perfect square that goes into these. The square root of 4 turns into 2, and 7 is going to stay as a radical. Now, on J, notice your index has changed. Be careful and watch that. Your index has changed. So we're looking for a cube root. So I'm looking at my cube root list. And I'm looking at, does 1 go into 32? Does 8 go into 32? Does 27 go into 32 evenly? Well, 8 is the number that goes into 32 4 times. The cube root of 8 is 2. And the 4 is going to stay right there. Now, we get to a perfect fourth on this one, or an index of 4. What I would do is check to see if that is a perfect fourth. You can check on your calculator. You can check in Desmos, type it in Desmos, and use it. So the fourth root is going to be, let's see. Okay, so that one doesn't give us a perfect fourth. Okay, so what we got to do is we have to find a perfect fourth. So we're looking for numbers that go evenly into 1200. That will give us that. So what I'm going to start with is I'm going to do like 2 to the 4th power. 2 to the 4th power gives me 16. And I'm going to see if 1200 is divisible by 16. Okay. So 2 to the 4th power. So here was my thought process. I checked 2 to the 4th power. That gave me 16. So I know 16 is a perfect fourth. That's what I know. And I know 16 will go into 1200. So I have -5 times the 4th root of 16 times 75. Okay, so I've got the -5 on the outside. 16 turns into a 2. And 75 is going to stay in the radical. And then what we need to do is we need to multiply these numbers here. So -5 times 2 is -10. And then the 4th root of 75 will give us our answer. Okay. So here are some problems for you to try on these. So what I would do if I were you, just pause the video and go through these real quick, and then you can replay or start playing the video again to check and see if you got them correct. So for A, you're looking for a perfect cube that goes into 750. And that's going to be 125. 125 is a perfect cube, and it goes into it 6 times. The cube root of 125 is 5. Oops, that should be a 3. And then our 6 is in the radical. Okay, we're also looking for a perfect cube for B that goes into 162. You're looking at the cubes list. So I'm just going to see what number is divisible. Let's see here, 162. All right, so 27. You should have gotten 27. And the cube root of 27 is 3. And then for C, 24, now it's back to a square root. Make sure you're paying attention to your index. So 4 times 6 will give us that. Square root of 4 is 2. 6 is going to stay in the radical. Okay, so moving on to example 3. So for variables, when we get to variables, what you want to do is you want to divide the power by the root. Divide the power by the root. However many times the root goes evenly into the power is the power of that variable on the outside. Then if you have a remainder, if there is one, that will be the power on the inside. So first of all, what I'm going to do is I'm going to fix the 75. 75 can be reduced because I know I've got 25 times 3. Now remember, if it's just a square root, it's got that invisible 2 right there. We just don't normally write it. So if you want to write it for now to help you remember what you're going into is fine. So you're going to ask yourself, how many times does 2 go into 4? 2 goes into 4 for my x 2 whole times. So 2 times. Now there's no remainder, so I don't have to worry about an x on the inside. Okay, I'm going to do the same thing for y. How many times does 2 go into 7? 2 goes into 7 3 times. Okay, 2 times 3 is 6. So I have a remainder of 1. Okay, 2 went into 7 3 whole times. That gets you up to 6, which means your remainder is 1. And then if I clean this up on the inside, I've got x squared. Oops, actually, I need to do my number first. Always put your numbers out front. Square root of 25 is 5. And then x squared, y to the 3rd. That 3 stays, and the y is going to stay in the radical. Okay, so for B, we're doing a 5. So I'm trying to see if there is a perfect fifth that will go into 224. And that's actually going to be 32. 32 times 7. And now I'm going to do 5 into 7. How many times does 5 go fully into 7? It goes once. So r to the first is on the outside. So if 5 goes into 7 one time, that puts you at 5. 5 to 7, you've got a remainder of 2. So then if I clean this up, the 5th root of 32 is 2, r. 5th root is 7r squared. Okay, so for example C, same thing. Now if we do our index into the power, 3 doesn't go into 2. So I can't do anything with the x. My index will not fit in my power. If the index is bigger than a power, you can't simplify it. All right, how many times does 3 go into 5? 3 goes into 5 one time with 2 left over. Now for my z, 3 goes into 9 2 times. 3 times. 3 goes into 9 3 times, and there's nothing left over, so there's no z. Now, we normally don't put that power of 1 there, but I just put it so you could, follow what I was saying. But for your final answer, you'll have y, z to the third, times the cube root of x squared, y squared. Okay, so now on D, we've already got something on the outside. So I'm just going to write it in front, because if I get anything on the outside in the end, I'm going to multiply those. Now, remember, my index for this is 2. It's an invisible 2. But sometimes I like to write just to remember what number I'm using. 2 goes into 7 3 times, so I have a to the third on the outside. My remainder is going to be 1, so I have a to the first on the inside. Then 2 goes into 6 3 times with no remainder, so no b on the inside. And 2 for my c, 2 goes into 3 once with a remainder of 1. Now I got to clean this up because I can add exponents. So for these, I can add my exponents. A to the second, a to the third is going to be a to the fifth. B and b to the third would be b to the fourth. And then I just have that one little c there. And then I have the square root of AC. I'm not going to put those powers of 1 because you don't normally write the ones. So for E, I'm going to go ahead and do the cube root of 27. 27 is a perfect cube. That's 3. Then 3 will go into 4 one time. And let's see here. I have a remainder of 1. Then 3 will go into 5 one time for y, and I have a remainder of 2. Remember, we don't normally put those 1s, so I'm just going to go back and get rid of those and clean that up a little bit. Okay, for F, we've got the square root of 8m to the third into the 11th. So if we fix the 8, 4 is a perfect square, 4 times 2. If I go ahead and do my m's, remember our index is 2. 2 goes into 3 once, and I have a remainder of 1. 2 will go into 11 for the n 5 times with the remainder of 1. So when I clean this up, the square root of 4 turns into a 2, so 2 comes to the outside. I have 2m into the 5th, and the square root, so this 2 stays on the inside. mn. Okay, so now we're to the part where you can try these yourself. So I would pause the video, try these, and then play the video to check your answers. So for A, it's a square root. Now, a lot of times you're not going to see that 2 there. I'm not sure why that 2 is there, but it is a square root. So you're trying to figure out perfect squares that go into 128, which is going to be 64. 64 times 2. All right, 2 goes into 8 4 times. All right, now if I clean this up, the square root of 64 is 8 into the 4th, and then this 2 is not a perfect square. It stays in the radical. All right, let's see here. 56, we've got to find a perfect cube that goes into 56, which is 8. 8 times 7. 3 will go into 5 for my x one time with the remainder of 2. And remember, this is a power of 1. 3 doesn't go into 1, so we can't do anything to the y. It's just going to stay there. So when I clean this up, the cube root of 8 is 2. And I've got x. Then there's my 7x squared y. For C, if I'm trying to find a perfect fourth that will go into 448, that's going to be 16 and 28. 16 is a perfect fourth. So for my x, 4 goes into 7 one time with the remainder of 3. Oops, that should be an x. And for my y, same thing. 4 goes into 7 one time with the remainder of 3. So when I do my numbers, the fourth root of 16, I'm be careful and don't do a square root. Fourth root of 16 is 2, x, y. And then I got the fourth root of 28, x to the third, y to the third. Okay, example 4, multiplying radicals. To multiply radicals, multiply your coefficients, then multiply your radicands, and then reduce. So if we multiply these, this is basically just distributive property. So I'm going to do square root of 2 times square root of 2 and square root of 2 times square root of 8. If they're both inside a radical, you can multiply them together. Now, a shortcut, which some of you may already know, if you have the exact same number underneath the radical, that radical just goes away and it's just going to become 2. Square root of 2 times square root of 2 is 2. Because think about that. If we multiply those numbers, square root of 2 times square root of 2 gives me square root of 4. Square root of 4 is 2. So that's a little shortcut you can use. All right, square root of 2 times square root of 8, just multiply 2 times 8, which is 16, but leave it under the radical. All right, we can take that a step further because 16 is a perfect square. It's 4, and then 2 plus 4 is 6. Okay, so for B, what I always refer to it as a multiply your outside numbers, multiply your inside numbers. So if we're doing 4 square root of 3 times square root of 27, 4 is the only outside number, so I'm just doing this one first. 4 is the only outside number. 3 times 27. Oops, let's see here. Is going to be 81. Now I know I'm going to be able to reduce that, but I'm going to go ahead and multiply my next part. 4 times 4 is 16. And remember, we got the same radical again right here. Square root of 3 times square root of 3 is 3. All right, square root of 81 is 9. 16 times 3 gives me 48. So now I just need to reduce 4 times 9 plus 38. And I can just type that in my calculator, which gives me 84. Okay, so C, D, and E are all, actually C, D, E, and F are all just examples of multiplying the same radical. Square root of 3 times square root of 3 is just 3. Square root of 2 times square root of 2 is just 2. It's like the radical cancels out. Square root of 5 times square root of 5 for E is 5. On F, square root of 300 times square root of 300 is 300. All right, for G, we've got the square root of 3 squared. Remember, this is a 2. Well, think about that. 2 goes into 2 one time. Oops, didn't mean to do that. So 2 goes into 2 once, you're just left with 3. So anytime you're taking the square root of something that is squared, your answer is just going to be whatever that part is right here. So H is going to be x plus 2. For I, it's the square root of something that's squared, so you're just left with x minus 6. Okay, for J, I'm going to multiply my outside numbers. 3 times 4 is 12. Then I'll multiply my inside numbers. 21 times 14 is 294. Now, I need to reduce 294. I need to figure out a perfect square that will go into that. So that's going to be 49 and 6. Square root of 49 is 7. And then I have square root of 6. Then I can multiply my 12 times 7. And that's going to give me 84. Square root of 6. So for K, multiply. So everything's on the inside here. So 15 times 6 is going to give me 90. X to the 4th and x. So add those exponents, you get x to the 5th, and then we're going to get y to the 7th. So if I think of a number, a perfect square that goes into 90, that's going to be 9 times 10. Remember, my index is 2. 2 goes into 5 2 times with 1 left over. 2 goes into 7 3 times with 1 left over. Now I need to take the perfect square of 9, which is 3. And my 10xy stays. Okay? So now we get to the point where you can try. So if you want, pause the video and you can try these 3 problems and then play it when you're ready to check your answers. So on A, multiply 2 times 3 is 6. And then 7 times 14 is going to give you 98. And we'll get t to the 3rd. So a perfect square that goes into 98 is 49 because we got to reduce it. 2 goes into 3 one time with 1 left over. So then I've got 6t, 49, the square root of 49 is 7. And then that 2t is on the inside. And then I just need to multiply 6 times 7 is 42. So I have 42t square root of 2t. On B, everything's on the inside. 2 times 9 gives us 18, and we get a to the 4th by adding those exponents. So if we break up 18, it actually breaks back up into 9 times 2, what we just had. Okay, and then 2 goes into 4 2 times for my A, no remainder. Square root of 9 is 3, so I have 3a squared square root of 2. And then on C, 7 times 3 are my outside numbers. I get 21. And then square root of 100, 5 times 20, and then x to the 6th. And 100 is a perfect square. That turns into 10. And 2 goes into 6 3 times. 21 times 10 is 210. And then I get x to the 3rd. And that concludes this part of this note.